Hello everyone and welcome to the world of objects. In the previous lesson, we learnt of the existence of libraries and their importance, and we started to see how tables and dictionaries are prevalent everywhere in Luau. In this lesson, with everything we've learnt so far, we'll step foot into the world of objects and see how we can create and manipulate them. First of all, what is an object? If you remember from the first lesson, we learnt about the workspace service and how it is the container for all the objects we see in a game as a player. For example, your house in Brookhaven, your rainbow unicorn in Adopt Me, and even the avatar you control in games, these are all objects located in the workspace. And all objects have properties that can define their appearance or functionality. For example, an object can have a color property. It can have a CanCollide property, which determines whether the object can collide with other objects or will it simply pass through them. Let's try creating our own object and see what we can do with it. We can create a simple part, which is just the name of a block in Roblox. To create one, hover over the workspace service in the Explorer and click on the plus icon next to it. This should drop down a list of objects that can be created, but personally, I find this drop down menu a little bit small. If you'd like to expand this view, you can click on the button next to the search bar, and now you can see all the objects much more clearly. Now let's search for part and click on it. This should create a simple block in our workspace. We can drag it around with our mouse, and if you press F on our keyboard, the camera should focus on the part, and you can change your camera speed with this slider at the top. But now that we have this part, what can we do with it? If we click on the part and look at the properties widget, it shows us most of the properties of this part that we can change. We'll go through the important ones together. As for the rest, you can learn them in your own time. For example, we can change the part's brick color, and it gives us a set of colors to choose from. We can toggle the cast shadow property, which determines whether the game should create a shadow for the part or not. Our part also has a color property, which lets you choose from a much wider range of colors than the brick color property. It even has a pick screen color option and the options to choose a color using HSV, RGB, and even hex values if you're familiar with them. We can change the part's material, and this option gives us a list of materials to choose from. Currently, the material of our part is plastic. We can change it to something like smooth plastic, and now it no longer has that rough texture to it. You can play around with the other materials and choose a material you like. We can also change the part's reflectance, and this property determines how shiny the object is. At 0 reflectance, the part isn't shiny at all, and at a reflectance of 1, the part is completely shiny and you no longer see its original color. We can also change the part's transparency. This property determines how see-through the part is. At 0, the part isn't see-through at all, it's completely opaque, and at a transparency of 1, the part cannot be seen at all, it's completely see-through. We can even change the part's name. Currently, the name of our part is simply part, but we can change it to something else, like block. Changing the name of an object updates the Explorer as well, so it now shows the new name of the object. And in fact, we can even change the name of an object directly in the Explorer by double clicking on it. Another property we can change is the parent, but we'll get back to this later. You might have already noticed that some properties are grayed out, like class name. As mentioned in the first lesson, a grayed out property means it cannot be changed, it can only be read. The class name property tells us which class this object belongs to. Objects are split into different classes, each with their own unique features. So far, we have come across 3 classes of objects: the simple part, which is the basic building block of a Roblox game, the spawn location, which controls where players spawn when they join a game, and the script object, which runs code. The functionalities of each of them make them unique from each other, so they are separated into their own classes. So the class name of the spawn location object is spawn location, and the class name of our block is part. The class name of the base plate is also part because it's just a huge part. It has no unique functionality that the block cannot do. And we'll understand the importance of these classes when we try to create new objects through scripting. The next property we'll look at is size. The size of this part is determined by these 3 numbers. Each number tells us the size of the object along a particular axis. So the first number, 4, tells us the size of the object along its x-axis. The second number, 1, tells us the size along its y-axis. And finally, the third number tells us the size along its z-axis. Together, these three numbers make up a vector. But if you're not familiar with what axes and vectors are, imagine an empty space and look at the center of it. From the center, we can move right and left, up and down, and back and forward. And these directions make up axes. Right and left make the x-axis, up and down make the y-axis, and forward and back make the z-axis. So you could think of axes as imaginary lines that we can travel along. But notice how each axis is pointing to one direction. If we want to move to the right, we move along the x direction. But if we want to move to the left, we move along the negative x direction. And this logic is the same for all axes. So to move up, we move along the positive y direction. And to move down, we move along the negative y direction. To move backward, we move along the positive z direction. And to move forward, we move along the negative z direction. So using these three axes, we can move to any point in a 3D world. And the direction from one point to another is known as a vector. If we want to find a vector that takes us from the center of the world, also known as the origin, to this point here, 4, 1, 2, we move along each axis until we reach it. So starting from the origin, which is the point 0, 0, 0, we move 4 spaces along the x-axis, 1 space along the y-axis, and 2 spaces along the z-axis to reach this point. And this gives us the vector of 4, 1, 2. It tells us the direction and the distance we need to travel in from the center to the point. And each number in the vector is known as a component, 4 being the x component, 1 being the y component, and 2 being the z component. But be careful, don't assume that vectors are the same as points. Let's say we want to move from the point 412 to the point 712. We would move 3 spaces along the x-axis, 0 spaces along the y-axis, and 0 spaces along the z-axis. And this gives us the vector of 3, 0, 0. It tells us how to move from one point to another. However, you might be wondering how any of this is relevant to the size of an object. If you look back at the size of our part, it says the size is a vector of 4, 1, 2. This means that the part fills the area between the origin and the point 4, 1, 2. So the part is created using these 2 points as opposite corners. So if you want to create a part with a size of vector 1, 1, 1, the part would use the origin and the point 1, 1, 1 as opposite corners and fill that area. Another thing to take note of is that the unit for measuring length in Roblox is studs. So the part is 4 studs long on the x-axis, 1 stud tall on the y-axis, and 2 studs wide on the z-axis. Now the next properties we'll look at are the position and orientation of the part. The position simply determines where the part is located in the world, and the orientation determines how the part is rotated. These two properties are part of the larger C-frame property, which is a lot more complex, and we'll go over it in more detail in a future lesson. But try not to get confused here with the other properties that say position and orientation under the origin and pivot offset. We just need to focus on the ones under the C-frame property. These two properties must also take vectors as the values they can be assigned to. We can change the position so that it is 10 studs high from the origin by changing its y component to 10. We can even change the x and z components to 0 so that the part is back in line with the origin, but still 10 studs high. As for the orientation, changing any one component will cause the part to rotate around that axis. So if we change the x component of the orientation to 45 degrees, the part will rotate 45 degrees around the x-axis, so it will rotate around this red line. And this is the same for the other components. Moving on to the final few properties that we'll look at, we have the CanCollide and Anchored properties. Whilst the CanCollide property is enabled, the part will collide with other objects, so it will not pass through them. If you press play to start the game, let's observe what happens to this part. As you can see, it fell down and hit the base plate. But you might not have actually seen this happening. When I joined the game, the part was already lying on the base plate. I joined too late to see anything happen. We'll learn why this happens in the upcoming lessons, but for now, if you click on the arrow underneath the play button and click on run, this allows us to view the game in motion, but not as a player, which lets us see any changes in the game almost immediately. And this time we see the part falling to the base plate. But if we disable this CanCollide property, what do you think will happen when we click Run? As you saw, the part falls, but it passed straight through the spawn location and base plate. It didn't collide with anything. So the CanCollide property determines whether the object can collide with other objects or not. As for the anchored property, if you enable it and press Run, this time the part stays in place. It has been fixed to its position and orientation. It will not be affected by physics. If we click Play instead and join the game, we will be able to pass through the part, and it won't move in response to any collision, because the CanCollide property is off and the anchored property is on. If you set the CanCollide property back to true and play the game again, we'll be able to jump on the part and stay above it. So this is what the anchored property can do. It fixes an object to its position and orientation and will not let it be affected by physics. Now we've learnt all of these properties and how to edit them in Studio, but how do we change these properties in a running game? Let's say after 3 seconds of starting the game, we want to change the part's color to yellow. To achieve this behavior, we must script it. So let's create a script object in server script service. Now to make any changes to the part in our code, we need to locate and gain access to it. Currently, the part is inside the workspace service, and if you look back at the parent property of the part, which is skipped over earlier, it says workspace. The reason why this is significant is because all objects you see in a game have something like a parent-child relationship. The part is inside the workspace service, so it is a child of the workspace, and the workspace is the parent of the part. The base plate is also a child of the workspace, and the workspace is its parent. The base plate has its own child as well. If you expand it in the Explorer, you should see a texture object. This object is a child of the base plate, and the base plate is its parent. Also, this object is a descendant of the workspace, and the workspace is its ancestor. Even the workspace and all of the other services have a parent, but we just don't see it in the Explorer. The parent for all of these services is the game. The game itself is the parent for all of these services, so every object we see becomes a descendant of the game. So it's sort of like a family tree. The fact that all objects in a game have a parent-child relationship is important because we can use this knowledge to locate objects in our code. So let's do that and store it in a variable. So we start from the highest point in the tree, which is the game, and we move down until we reach the part. So from game, we'll move to workspace, and to do that, we index game with the name of its child, workspace. Since the name is a string without any spaces, we can do game, square brackets, workspace, or game dot workspace. I prefer the dot method as it's much easier to read and write, and it's the preferred way of most other scripters. So I'm going to write dot workspace. And finally, we move up to the part, which is a child of the workspace. Remember to index workspace with the name of the part. I named the part block, so I'm going to write dot block. Now we've located the part in the game and should have access to it in the script. Let's print the variable to see what it stores. And it shows block. Perfect. If you click on it, it should highlight the part in the Explorer. However, if this didn't work for you, make sure the names of the objects in your code are consistent with the names in your Explorer, and make sure you don't miss out any capital letters because all names are case sensitive in Luau. Now we can manipulate the part's properties in the script. After a 5-second delay, let's change the part's transparency. To do that, in a new line we can add a wait statement. So wait parentheses 5 seconds. Then we index the part with the name of the property we want to change. Just like before, we can either index with square brackets or a dot, since the name of the property is a string with no spaces. Now we set the transparency to a value it supports. The transparency property takes a number between 0 and 1, so we can set it to something like 0.5. And let's test this. After a short delay, the part's transparency should change. And it works. Nice. We can try manipulating the anchored property of the part. The anchored property can be set to either true or false, so it takes a boolean. Since the anchored property is already enabled, we can set it to false in our script and see what happens. And after a 5-second delay, it falls. Let's try changing the material of the part. I want to make the part a little bright, so I'm going to change the material to neon. In our code, we index the material property of the part and set it to a value it supports. But what type of value does material support? Whenever a property has a drop-down box like this in the properties widget, where it lets you choose from a list of options, you can find these options in your code using the enums data type. You can think of this enums data type as a large collection of all the default values in Roblox, like the default materials and shapes. And any property which has a drop-down box in the properties widget will have its own section in this enums list. So to change the material of the part to neon in our code, we need to find that material in the built-in enums list. And to access this list, we write the variable enum and index it with the name of the specific enum or specific section we are interested in. Since we are interested in materials, we write enum.material, and then we index this section with the name of the specific enum item we want. You can choose any material you like, but make sure it is compatible with parts or base parts. Now, before we test the code, I'm going to reduce the transparency to 0.2 so we can see the material properly. And you can see the material changes after 5 seconds. In fact, we can set the material directly using a string. The code will still work fine, however this method is more prone to mistakes because there is no auto-completion to help us write the name correctly, and we don't get to see any of the other options in the list either. This is why it's much better to use the enums data type when changing properties like the material. If you want to change the shape of the part, we do part.shape equals enum dot. Now, Roblox decided to name the shape's enum as part type instead of simply shape. Normally, the name of an enum in the enums list is the same as the property name, like it was for material. However, shape wants to be a little different. So we write enum dot part type and we index it with the name of the specific shape we want. We can do ball, which is just a sphere. And let's test the code. And the part shape changed to a sphere. If you do ever forget the name of the enum you need, when you are typing the property name, on the right hand side it shows a box which tells you what type of value the property expects. So far we have used values of different data types to manipulate the part's properties. We've used numbers, booleans, and even a new data type called EnumItem. But if you want to change the color of the part, what type of value do you think this property supports? Let's start with the brick color property. This property is unlike the ones we've changed so far. Unfortunately, we don't have a ready-made list of brick colors to choose from in our code. We need to create the brick color we want using the brick color constructor function called brickcolor.new. We can pass the name of a brick color to this function as an argument, and the function will return the brick color with that name. I'll choose bright orange, and let's see if this works. Perfect. As for the color property, we need to construct a color3 value using one of the color3 constructors. I prefer using the fromRGB function, but you're free to choose any of the others. This function takes three numbers which represent the red, green, and blue values to produce a color. When using a color3 constructor, a color wheel should appear beneath it, which allows you to get the correct values you need to create the color you're looking for. And once you've chosen your color and applied it to the part, let's test the code. And it works. Now we've seen different ways of how we can change the appearance of our part through code, but how do we change its size? Earlier in the video, we learned that the size, position, and orientation of parts are represented by vectors with three components. So we need to create a vector3 value using a constructor. We can use the vector3.new function and pass three numbers to it, which represent the x, y, and z components. I'll just pass 3 for each of them. Now let's test the code. And it works, the part size changed. And finally, let's try changing the position of the part. After a 1 second delay, I'll set the new position of the object to vector3.new, 5 on the x, 10 on the y, and -5 on the z. Now let's test the new code. After a short delay, the object changes appearance and falls down. waits for another second, and then moves. Perfect. So far, we have manipulated the properties of a ready-made object from Studio. We just had to locate it. However, there are many times when we would want to create an object from scratch in our code. For example, we might want to create acid rain and drop some green parts every second from the sky. Roblox provides us with a function to construct an object from scratch, and this function is called instance.new. So let's comment out the first line, and instead of fetching a part from the workspace, let's create one using instance.new. So local part equals instance.new. Inside the parentheses of the function, we specify which class of object we want to create. We just want to create a part, so we'll send the class name part to the function. Then we can set the properties we want the part to spawn with. I'll set the anchored property to true, and the position to vector3.new 0, 10, and 0. And parts spawn in with the CanCollide property already enabled, so I'm not going to change that. Now the code should work the same as before, right? We've created a new part, but set the same properties that our first part had, and manipulated them in the same way as before. But before we test the code, I'll move the old part to the server storage to keep it out of the way. And nothing happens. If we look back at our code, can you spot the cause of our problem? Let's try printing the parent of the part and see what it says. It says nil. The new part's parent is not the workspace, which is where we see the game in motion. Its parent is currently nil because we haven't set it to anything yet. So to fix this issue, all you have to do is set the part's parent to the workspace. So part.parent equals game.workspace. And now if we test the code, it works perfectly. So this is how we manipulate an object's properties in our code. We firstly locate the object or create one, then index it with the names of the properties we want to change and set them to values they support. And this is the essence of scripting a game. We create objects and manipulate them in a certain way to create a particular scene for the player. Some final notes: a simpler way of writing game.workspace is to use the built-in variable workspace instead. This variable holds the workspace service by default, so instead of writing game.workspace.block, we can write workspace.block. Make sure to write this workspace variable in all lowercase letters, otherwise it won't work. And keep practicing what you've learnt so far, and try to bring all your knowledge together. As for an assignment, try to create something like multicolored rain. So continuously spawn in parts of different sizes and color in random positions in an area so it looks like rain. You've learnt everything you need to create something like this. It's up to you and your imagination to bring it to life. But that's all for this lesson. There was a lot to cover and it took a long time to make this video. I hope I've explained everything properly and not missed anything out. And if you do have any questions, please feel free to ask them in the comment section and I'll try to respond as soon as possible. Thank you all for watching. I hope you all have a wonderful day and I'll see you in the next one.